Welcome to yet another session of electronics. Today we are going to talk about narrowband Internet of Things, which is known as NB-IoT. This is a multi-part video. Many more videos are going to come. So, these videos based on academy.nordicsemi.com. So all material are taken from them. So if you want more details, you can refer the link given here. NB-IoT is becoming more and more relevant in the coming days because many telecom operators are not going to support 2G and 3G in the coming days. So if you want to form a wide area network covering many kilometers or even entire pan India, then NB-IoT is one of the most suitable options provided there is a cell phone coverage in that area. For 4G signal coverage in that area, then NB-IoT suits best for connecting devices to the internet. This PCB is based on NRF 9160 from Nordic Semiconductors. This can communicate to internet through NB-IoT. The board which has been shown in the previous slide has been designed in our lab, and we are going to discuss the features in general of NB-IoT based on the information available in the Nordic Semiconductor website. The board has been designed to track and assess the location, the altitude, the vibration, the noise around the asset can be monitored using the board shown above. Basics of cellular IoT. Cellular IoT refers to Internet of Things technologies developed by the third generation partnership project 3GPP to enable IoT communications using cellular networks, thus leveraging already existing infrastructure. Two of the most prominent cellular IoT technologies are LTE-M and NB-IoT, which use an LTE variant tailored specifically for IoT. The first part of the cellular network is the device called UE, user equipment, communicating with a cellular tower called ENB, evolved node B. The UE sends uplink signals to the ENB and receives downlink signals from the ENB. This part of the network is referred to as E-UTRAN, Evolved Universal Mobile Telecommunication Systems, UMTS, Terrestrial Radio Access Network. Beyond the connections between the UE and the ENB, the E-UTRAN communicates with the Evolved Packet Core, EPC, which then enables communication with the Internet. The EPC is composed of several functional entities, most notably the Mobility Management Entity, which manages the connections with the UE and the PDN Gateway, which is a gateway to the Internet. The need for new cellular technologies. Until recently, things like better quality phone calls and faster internet connections has been the main driver behind the advance of cellular technologies. But with the rise of IoT, a new profile of applications has emerged, giving cellular technologies a new direction for growth. This new application category is called Machine Type Communication, known as MTC. MTC differs from human-generated traffic in both nature and requirements. Consider two people having a phone call. Data packets are sent very frequently and in long bursts, requiring very low latency, and traffic is usually symmetric between uplink and downlink. On the other hand, for MTC, data packets are shorter. Some delays might be acceptable. Traffic is mostly uplink, meaning most signals are sent from the UE and the number of connected devices per ENB is massive. It's clear that MTC requires different technology than what standard LTE can offer. To meet these new MTC requirements, 3GPP Release 13 introduced the two cellular technologies, LTE Cat M1 and LTE Cat NB1, also known as LTE-M and Narrowband IoT, NB-IoT respectively. The 3GPP third generation partnership project is the body responsible for developing cellular technologies, and the standards are structured as releases. Although both technologies were developed with the MTC use case in mind, there are some key differences that need to be understood before selecting which one to use in your application. In India, only NB-IoT is available and not LTE-M. Technical comparison. Choosing the most appropriate cellular IoT technology is key to creating a stable, future-proof and cost-effective solution. LTE-M and NB-IoT, despite both being LTE-based IoT enablers, have some differences which, when understood correctly and taken into account, can save resources and time. Let's discuss some key parameters and see how LTE-M and NB-IoT compare. Bandwidth. LTE-M offers 1.4 MHz while NB-IoT offers 200 kHz only. Maximum data rate. LTE-M offers 300 to 350 kbps and NB-IoT offers only 30 to 60 kbps. Typical range estimate 11 km for LTE-M and 15 km for NB-IoT. So NB-IoT offers higher range. Latency. LTE-M offers 50 to 100 millisecond while NB-IoT offers higher latency of 1.5 to 10 seconds. Mobility is supported by LTE-M, that is, devices can move around in LTE-M, but that is not supported in NB-IoT. Roaming is supported in LTE-M, but limited support for NB-IoT. With respect to deployment density estimate and battery lifetime, both are almost same. Let us conclude this video at this point, and then we will continue our dialogue on NB-IoT in the next video. Till then, see you. Tata. Bye bye.